very easy to slip up on this question, I think. So sets of three consecutive integers. That means they're one after each other. Now let's look at, say, 7, 8, and 9. 7 plus 8 plus 9 there's no way that that is going to equal 7 times 8 times 9. This is much, much bigger. And that's what we mean by the sum. That's adding. And the product is when we're timesing. So they're going to have to be smaller than that because as you make the numbers bigger, it's going to get even worse. So let's look at the smallest kind of positive integers, and that would be 1, 2, and 3. Well, 1 plus 2 plus 3 is equal to 6, and 1 times 2 times 3 is also equal to 6. So we've got one. That's going to be a solution. It's just whether there's any more. Well, if you go with 2, 3, and 4, that's not going to work. You're going to get 24 by multiplying and only 9 by adding. So no, we're going to need to look at negatives because actually, you can even see this, it doesn't have 1 in the answer, so it's got to be more. Well, what about -1, -2, and -3? If we add them, then we get -6. And if you times them, then actually you also get -6. So that is another solution. It might be very tempting to stop there and go with 2, but it is in fact not correct because the other one that you might easily miss is -1, 0, and 1. Because if you add them, you get 0. But if you multiply them, because you've got a 0 in there, then you also get 0. So those are our three solutions, and the answer is C. Now, maybe you're the sort of person that is not convinced by that. How do you know there's not any more? How can we prove it? And we can, in fact, prove it. One way of proving it is to write down these three consecutive integers algebraically. And sometimes people write n plus 1, n minus n plus 2, but a good strategy is actually to go with n minus 1, n, and n plus 1. When you start adding these things, it's really nice because the -1 and the 1 cancel. So let's find the sum. Well, actually, like I just said, they cancel and we're left with 3n. Then let's find the product. I've decided to write it like this because it's a really good idea to multiply this out first because I get a difference of two squares. I get n times n squared minus 1. This all depends on how happy you are with multiplying out three brackets. But if you multiply the double bracket first, n minus 1, n plus 1, then you'll get something that's not too bad when you multiply it out further. N cubed minus n. If you did it in a different order, then it'll be a bit more complicated, but you'll still get back to this answer. So therefore, we've got the n cubed minus n. The product is going to equal 3n, the sum. This is a cubic, but we can solve it. I can solve it by minusing 3n from both sides. N cubed minus 4n is equal to 0, and then factorizing it, a bit like you factorize a quadratic. The first thing to do is take out this common term of n. So we've got, common factor. So we've got n squared minus 4 equals 0. And then n squared minus 4 is the difference of two squares again. So it's going to be n minus 2, n plus 2 is equal to 0. And that gives us three solutions. A bit like when you have a quadratic, you're going to get 2 here. You just take the negative of this. You're going to get minus 2 here, and you're going to get 0. Don't forget about that one. So n is equal to 0, 2, or minus 2. Now remember what we had at the start. We had n minus 1, n, and n plus 1. So when n is 0, I'm going to get minus 1, 0, and 1. When n is 2, I'm going to get 1, 2, and 3. And then when n is minus 2, and I put it in, I'm going to get minus 3, minus 2, minus 1. This is really nice, I think. I mean, there's a lot more to it, but it is comprehensive. It's algebraic method, and we get our three solutions.